in the last class, we have seen the Coulomb's law. According to this law, the force between two charges is directly proportional to the product of charges and inversely proportional to the square of the distance between them. And this force is along a unit vector. Suppose this force is acting on the charge Q1 due to the charge Q2, then the direction of this force is along a unit vector pointing from the charge Q2 to the charge Q1, R21 cap. So where R21 cap is the unit vector from force charge Q2 to the test charge Q1. So Q1 is force acting on Q1 is test charge and Q2 is the source charge. So the force is always directed from the source charge to the test charge if both the charges are having same sign. So suppose Q1 and Q2 are positive, the direction of this force is along this unit vector and it is always acting along the test charge. So test charge move. So this force is repulsive. The test charge will get repelled due to this force. So this will just move along this direction. So, but if the charges are of opposite sign, one positive and negative, അങ്ങനെയാണെങ്കിൽ ഈ ക്വാണ്ടിറ്റിയിൽ ഒരു നെഗറ്റീവ് സൈൻ വരും. അപ്പോൾ അതിൻ്റെ ഫോഴ്സിൻ്റെ ഡിറക്ഷൻ എന്ന് പറയുന്നത് R21 എന്ന് പറഞ്ഞാൽ എവേ ഫ്രം ദി സോഴ്സ് ചാർജ് ആണ്. അപ്പോൾ ഇൻറ്റു ഒരു നെഗറ്റീവ് വരുമ്പോൾ ടുവേർഡ്സ് ദി സോഴ്സ് ചാർജ് വരും. സോ ദാറ്റ് ഫോഴ്സ് വിൽ ബി അട്രാക്റ്റീവ് ഇൻ നേച്ചർ. Q1 ഉം Q2 നെഗറ്റീവ് ആണെങ്കിലും രണ്ടും നെഗറ്റീവ് ആണെങ്കിലും പ്രോഡക്റ്റ് പോസിറ്റീവ് ആവും. ആൻഡ് അഗെയിൻ ദി ഫോഴ്സ് is directed away from the source charge. So if the charges are having opposite sign, then there is a negative sign in its magnitude itself. The forces towards the source charge. Similarly, we can find the force acting on Q2 due to Q1 in the same manner. So if the charges are of the same sign, then the force is repulsive and acts from the source charge towards the test charge. So if the charges are of the opposite sign, then the force is repulsive and acts towards the source charge. അപ്പോൾ ഈ യൂണിറ്റ് വെക്ടർ ഇടുന്നതിൽ ഇത് നമുക്ക് മാറുന്നില്ല കേട്ടോ. വെദർ ദി ചാർജസ് പോസിറ്റീവോ നെഗറ്റീവോ ഡിപ്പെൻഡ് ചെയ്യുന്നില്ല. എപ്പോഴും അതിന്റെ യൂണിറ്റ് വെക്ടർ എന്ന് പറഞ്ഞാൽ if the force is acting on Q1 due to Q2 ആണെങ്കിൽ it is along R21. So extra negative sign if the charges are of the opposite sign comes in the magnitude. അപ്പോൾ അതുകൊണ്ടാണ് നമുക്ക് ഡിറക്ഷനിൽ ഒരു മൈനസ് എക്സ്ട്രാ വരുന്നത്. ബട്ട് നമ്മൾ ലോ എഴുതുമ്പോൾ എപ്പോഴും R21 cap എന്ന് എഴുതാം. If the force is acting on charge 1 due to charge 2. So this equation is true when the charges are placed in free space or vacuum. And we can use this equation for air also. For medium other than free space, air or vacuum, we cannot use this equation. So for any other medium, the magnitude of the force is equal to 1 by 4 pi epsilon Q1 Q2 by R square. So this is the magnitude of the force. Direction is along R21 if the force is acting on the charge 1 due to charge 2. So we will not specify the direction now onwards you are clear about this deduction. So here in the free space we have seen that epsilon 0 is the permittivity of the free space. Permittivity of the free space. So in a medium we have to use epsilon, which is the permittivity of the particular medium concerned. Permittivity of the medium. So the magnitude of the force is 1/4 pi epsilon Q1 Q2 by R square. So in the case of the medium, we can define a quantity called the relative permittivity, epsilon R, which is also known as the dielectric constant of the medium. Dielectric constant of the medium. And it is defined as the ratio of the permittivity of the medium to the permittivity of free space. So the epsilon R is the ratio of permittivity of the medium to the permittivity of free space. It is also called the dielectric constant, and therefore it is also represented by a letter K. So here this quantity is a dimensionless quantity because epsilon and epsilon 0 are both permittivities, and therefore they are having same dimension. So we can cancel the dimensions of the numerator and the denominator, and therefore this quantity epsilon R is dimensionless. So this quantity characterizes the electrical properties of the medium. So we know that for free space the epsilon R is equal to free space in epsilon R in the epsilon 0 and epsilon 0 by epsilon 0, which is 1. So for any other media the epsilon R is greater than 1. So that means the permittivity of any other media is greater than the permittivity of free space. So epsilon by epsilon 0 is always greater than 1. The numerator is always greater than the denominator. And therefore, for any other media, the epsilon R is greater than 1. So for free space or vacuum, it is 1, and for any other media it is greater than 1. So since epsilon R is equal to epsilon by epsilon 0, we can write epsilon as epsilon 0 multiplied by epsilon R. So substituting this in the equation, we will get the force between two charges in a medium having relative permittivity. Epsilon R is equal to 1/4 pi epsilon 0 epsilon R Q1 Q2 by R square. So this is the magnitude of the force. We have seen that the value of epsilon R is greater than 1 for any media other than free space or air. So the values for different media can be tabulated. For air it is 1.005, so it is approximately taken as 1, and for paper it is 2 to 2.5, and for mica it is 3.6, and for water it is 8. So for metals, we will see that for conductors, the value of the dielectric constant is infinity. So we can see that since the epsilon R comes here in the denominator, the force in any other medium is less than the force in free space. So this is the force in vacuum, and this is the force in a particular medium. So this is 1 by 4 pi epsilon 0 q1 q2 by r square. So F vacuum divided by F medium is equal to 1 by 4 pi epsilon 0 q1 q2 by r square divided by 1 by 4 pi epsilon 0 epsilon r q1 q2 by r square. So those terms will cancel and we have 1 divided by 1 by epsilon r, which is epsilon r itself. So the force in vacuum is epsilon r times greater than the force in medium. Or we can also define the dielectric constant of the medium as the ratio of the force between two charges placed at a certain distance in vacuum to the force between the same two charges placed at the same distance r in that medium. So നമുക്ക് അതിനെ epsilon by epsilon 0 എന്ന് define ചെയ്യാം. Similarly, it can be defined as the force between the two charges at a particular distance in vacuum to the force between the same two charges placed at the same distance r in the particular medium. So the force in vacuum is always greater than any other medium. So since epsilon r is greater than 1, the ratio is always greater than 1 and therefore greater than or equal to 1. For a free space it is 1, and therefore the force in vacuum is always the largest quantity compared to the force in any other medium. അപ്പോൾ നമ്മൾ ഒരു മീഡിയം നമ്മൾ പ്ലേസ് ചെയ്യുമ്പോൾ രണ്ട് ചാർജസ് നമ്മൾ ആദ്യം വാക്വത്തിലായിരുന്നു. എന്തിന് ഇൻ ബിറ്റ്വീൻ ഒരു മീഡിയം പ്ലേസ് ചെയ്യുമ്പോൾ ദി ഫോഴ്സ് ബിറ്റ്വീൻ ദാറ്റ് ടു ചാർജസ് ഡിക്രീസ് ബൈ എ ഫാക്ടർ ഓഫ് ദി ഡൈഇലക്ട്രിക് കോൺസ്റ്റന്റ് ഓർ ദി റിലേറ്റീവ് permittivity. So now we can generalize the Coulomb's law as F is equal to 1 by 4 pi epsilon 0 epsilon r q1 q2 by r square. So if the force is acting on the charge 1 due to charge 2, it is along the unit vector r21. So r21 is the unit vector pointing from the charge 2 to the charge 1. So this is the general form. So we can apply this equation for both free space and also for any other media. For free space, we can see that epsilon r is 1 and the equation will become 1 by 4 pi epsilon 0 q1 q2 by r square. So we have to remember that this law is true for point charges. For point charges എന്ന് പറഞ്ഞാൽ the size of the charges should be much smaller than the distance between them. So very large distance ആണെങ്കിൽ നമുക്ക് ഇതിന് കുറച്ചൊരു സൈസ് ഉണ്ടെങ്കിൽ കുഴപ്പമില്ല. പക്ഷേ in between ഉള്ള distance small ആണെങ്കിൽ we have to consider point charges. So point charges means the distance between these two charges should be very much greater than the dimension of the charges. ചാർജിനൊരു dimension ഉണ്ടാവും, അതിനേക്കാളും വളരെ ഹൈ ആയിരിക്കണം the distance between the charges. Then only the Coulomb's law is valid. The Coulomb's law is found to be valid for distances of a few femtometer, means 10 to the power minus 15 meters to a few kilometers. പിന്നെ ഡിസ്റ്റൻസ് കൂടുകയാണെങ്കിൽ R ഇൻക്രീസ് ചെയ്യും. സോ 1/r² is very very small and force tends to 0. അതുപോലെ മെറ്റൽസിന് ഇൻസൈഡ് നമ്മൾ പറഞ്ഞു എപ്സിലോൺ r ഇൻഫിനിറ്റി ആണ്. സോ ഇൻസൈഡ് ദി കണ്ടക്ടർ ദി ഫോഴ്സസ്